With the ignition in the on position, switch open, the opening of the breaker contact points interrupts primary current flow, resulting in rapid collapse of the primary coil field. Now, when your ignition switch is on in the on position, in that case your breaker contact points, when open, they will interrupt the primary current flow and will result in rapid collapse of the primary coil field. When the ignition switch is in the on position, the switch has no effect on the primary circuit. So, when your ignition switch is on, in that case it has no control, no effect over the primary circuit. In case of off position, as we have seen in a previous slide, this will provide path to ground. It will provide the primary current a path to ground, and the primary current is not interrupted even when the breaker points open. You can see in the figure, this is a common type of a switch which is used in reciprocating engines. So, it has 4 positions: off, left, right and both. Switch in off position. In case the switch is in the off position, you have both magnetos are grounded and thus are inoperative. So, in the off position, your both magnetos are grounded and they are inoperative. In case switch is in the left position, only the left magnetos operate. Switch in the right position, only the right magnetos operate, and switch in the both position, both magnetos will operate. The dual ignition systems are checked by placing the ignition switch in the right and left positions, which allows the magnetos to turn off one at a time. So, we will see in our further lectures how we check the ignition system. In case of dual ignition systems, they are checked by placing the ignition switch in right and left positions, which will allow the magnetos to be turned off one at a time. Now, certain precautions are to be observed while working on the ignition system. While working with the magneto system, the important point to be always kept in mind is that the magneto will be hot when the P lead is disconnected or when there is a break in the circuit leading to the ignition switch. So, magnetos will be hot when your P lead is disconnected or when there is a break in the circuit leading to the ignition switch. If the switch circuit is being repaired, it is important that the primary terminal of the magneto be connected to ground, or that the spark plug leads be disconnected. So, very important that in case the switch circuit is being repaired, in that case the spark plug leads should be disconnected. Now, another important unit in the ignition system is the impulse coupling. Initially, when the engine is started, the engine turns over too slowly to permit the magneto to operate. So, now initially when your engine is cranked, the cranking speed is too slow to permit the magneto to operate. So, the purpose of the impulse coupling is to give magneto a momentary high rotational speed and to provide a retarded spark for starting the engine. So, the basic purpose of the impulse coupling is to provide magneto a very high momentary rotational speed and to provide a retarded spark for starting the engine. So, the impulse coupling is installed on the drive shaft of a magneto and comprises of the following: shell, spring, hub or cam along with fly weights. So, here you can see this is the body, then you have the fly weights here, this is the cam and this is the spring. So, this impulse coupling, there are various parts: fly weights, cam, body, spring. It is spring loaded. It is a mechanical linkage between the magneto shaft and the engine. So, basically this is a spring loaded mechanical linkage between the magneto shaft and the engine, and we have seen the basic purpose of the impulse coupling is to provide a high rotational speed to the magneto and also to provide a retarded spark for starting the engine. It provides the high voltage necessary for ignition by winding up and letting go at the right instant for spinning the magneto shaft. Now, let us see the position of the coupling, impulse coupling in the start position. You can see the figure here, these are the fly weights and this is the stop pin in the magneto body and these are your fly weights and this is the body here, which is attached to engine drive. This body is attached to engine drive, and here these are your flyweights. These are the pivot points of the flyweights. This is the stop pin which is there in the magneto housing, and this is your trigger ramp on both sides. So with the magneto fitted with an impulse coupling, the shell of the coupling is rotated by the engine drive while the rotating magnet remains stationary. So on magnetos which are fitted with an impulse coupling, when the shell of the coupling is rotated by the engine drive, the rotating magnet remains stationary. So in that case, the rotating magnet is stationary, but the shell of the coupling is rotating by the engine drive. This causes the spring in the coupling to wound up. So when this body is moving, is being rotated, the shell of the coupling is being rotated. In that case, the spring in the coupling will wound up. At the instant when the magneto is supposed to fire, so at that very instant when the magneto is supposed to fire, the body which is contacting the trigger ramp, you see here in this case the body, since it has moved, it has rotated with the drive, this is touching the trigger ramp. In the previous picture, if you see, this body was away from the trigger ramp. In the second picture, now the body, since it has rotated and the rotating magnet was stationary, the body has moved, now it is touching the trigger ramp, it is contacting the trigger ramp. Because of this contact, the trigger ramp will release the flyweights. Because of this contact of the body and the trigger ramp, the flyweights will get released and it will cause the flyweights to rotate on the pivot points. Now because of this push here by the body on the trigger ramp, the flyweights will rotate on their pivot point and will disengage from the stop pin. So at the instant when the magneto is supposed to fire, the body which is contacting the trigger ramp will release the flyweights, causing the flyweights to rotate on the pivot point and disengage the stop pin. Now what will be the position of impulse coupling in the running position? As the flyweights rotate on the pivot point and disengage from the stop pin, the spring unwinds, giving the rotating magnet a rapid rotation in the normal direction. So as the flyweights disengage, the spring will unwind and it will give the rotating magnet a rapid rotation in the normal direction. The rapid rotation of the rotating magnet causes the magneto to produce a strong spark at the spark plug. So this rapid rotation of the rotating magnet will cause the magneto to produce a strong spark at the spark plug. In the engine running position, the centrifugal force will hold the flyweights in the release position. So here you can see the centrifugal force. Because of the centrifugal force, the flyweights are in the release position and the magneto fires in the normal advanced position. So in the running position, the magneto is firing in the normal advanced position and the flyweights are released. The impulse coupling holds back the magneto rotation during engine startup, thus furnishing a retard spark during engine starting. So during the engine starting, the impulse coupling is holding back the magneto rotation and will furnish a retard spark during starting. The impulse coupling spring holds the magneto in the advanced spark position during normal operation. So during normal operation, the magneto is in the advanced spark position. During the starting condition, the magneto is furnishing a retard spark. Now in case if during operation the spring breaks, the magneto will continue to operate but will be in the retard spark position, causing late firing of the spark plugs fed by this magneto. So now in case during operation if the spring fails, in that case also magneto will continue to work but will provide a retard spark and will result in late firing of the spark plugs which are fed by this magneto. Coming to spark plugs, the purpose of the spark plug is to convert the high voltage electric energy produced by the magnetos to heat energy to ignite the fuel air mixture in the engine cylinders. So the high voltage energy, electric energy which is produced by the magnetos, this will be converted to heat energy to ignite the fuel air mixture in the engine cylinders. The spark plug provides an air gap across which the high voltage of the ignition system produces a spark to ignite the mixture. So spark plug will provide an air gap across which high voltage produces a spark to ignite the mixture. So here in the figure you can see this is your central electrode, and here you can find the gap between the electrode, and this gap is there to provide a spark. The aircraft spark plug consists of three major parts. Electrodes, you can see in the figure here you have the electrode, then you have the insulator, and then you have the outer shell or the metallic shell. So three main parts: center is your electrode, then you have the insulator, and then you have the outer shell. The outer shell is made of finely machined steel, plated to prevent corrosion from engine gases and possible thread seizure. So the outer shell is made of finely machined steel, and it is also plated to prevent corrosion and possible thread seizure. It is threaded to fit into the cylinder, and the other end is threaded to receive the ignition lead from the magnetos. We will see actually how the spark plug is connected. One end is threaded to be screwed inside the engine cylinder, whereas the other end is also threaded to receive the ignition lead of the ignition harness. The cylinder gas pressure is prevented from escaping around the plug by using close tolerance screw threads and a copper gasket. Now, because there is high pressure in the engine cylinder and the spark plugs are screwed in the cylinder, we have to prevent pressure loss. That is prevented by providing close tolerance screw threads and a copper gasket. Pressure leakage through the plug is retained by inner seals between the outer metal shell and the insulator. So between this outer shell and the insulator you have inner seals, and also between the insulator and the center electrode. So in order to prevent the pressure leakage through the spark plug, you have inner seals provided between the outer shell and the insulator, and between the insulator and the electrode. A waterproof seal is provided between the lead and the plug to prevent moisture from entering this connection. So in between the lead and the plug, in that case also you have a waterproof seal which prevents moisture from entering this connection. The purpose of the insulator, you can see here the insulator is to provide a protective core around the electrode. So here you see this is your electrode and you have the insulator around it. The purpose of the insulator is to provide a protective core around the electrode and transfer heat from the insulator tip or nose to the engine cylinder, and it will transfer heat from the nose tip, from the insulator tip to the engine cylinder. Now this insulator is made from aluminum oxide ceramic. This is made from aluminum oxide ceramic which has excellent dielectric strength, high mechanical strength and thermal conductivity. Now this is made of aluminum oxide ceramic and has various properties. Spark plugs used in different engines vary in terms of heat range, reach, massive electrode, fine wire electrode or any other characteristic required as per installation requirements for different engines. So there are different types of spark plugs being used on engines. They are of different heat ranges, different reach, different types like massive electrode or a fine wire electrode or any other characteristic required as per the installation requirements. The massive electrode are so named because of the size of the center and the ground electrodes. In the figure if you see, this left figure, this is your massive electrode spark plug. You can see the electrode in the center. Because of the size of the electrode, center electrode and the ground electrodes, you see this is termed as the massive electrode. Massive electrode type spark plug is a resistor type that reduces electrode erosion. So this is basically a resistor type of spark plug. The center electrode comprises of a copper core with a nickel alloy sheath. So this center electrode, this is made of copper core and it has a nickel alloy sheath around it. The center electrode is sealed against gas leakage by a metal glass binder. So again provision is there to prevent gas leakage, and it is sealed, the center electrode is sealed by a metal glass binder. In the right figure, if you see this figure, these are your fine wire spark plugs. They are similar in construction to the massive electrode plug except for the electrodes. Here in the figure, if you observe the electrode in the center, this is as compared to the massive electrode, you can see this is a fine wire electrode. They are similar in construction except the center electrode. The center electrode of the fine wire spark plug is made of platinum. So this, in case of fine wire electrode, the center electrode is made of platinum and the two ground electrodes are constructed of either platinum or iridium. So these two ground electrodes, they can be constructed of either platinum or iridium, whereas the center electrode is of the platinum material. The use of platinum and iridium ensures maximum conductivity and minimum wear. So the platinum and iridium, they have the properties and it ensures maximum conductivity and minimum wear. Now the heat range of a spark plug is a measure of its ability to transfer the heat from the firing end of the spark plug to the cylinder head. So basically it is the measure of the ability to transfer heat from the firing end of the spark plug to the cylinder head. The plug must operate hot enough to burn off carbon deposits. At the same time, it should also remain cool enough to prevent a pre-ignition condition. So there are requirements of spark plugs where they need to be hot enough to burn off the carbon deposits, whereas at the same time they also need to remain cool to prevent any pre-ignition sort of condition. One of the important factors in determining the plug's heat range is the length of the nose core. So the length of nose core is very important in determining the plug's heat range. Hot plugs have a long insulator nose. So you can see here these hot plugs, this is the hot plug, you have the long insulator nose that creates a long heat transfer path. Because of this long path, it creates a long insulator nose, it creates a long heat transfer path. You can see the heat transfer path, this is long, this is your hot plug. Cold plugs have a relatively short insulator path. You can see cold plugs, they have a relatively short insulator path to provide a rapid transfer of heat to the cylinder head. So this will provide a rapid transfer of heat to the cylinder head. High compression engines tend to use colder range plugs, while low compression engines tend to use hot range plugs. So high compression engines will use cold plugs, whereas low compression engines will use hot range plugs. The spark plug reach is the threaded portion of the spark plug that is screwed in the spark plug bushing of the cylinder. Now you see, this is the threaded portion and this is the reach. We have read earlier that the spark plug has two threaded ends. One threaded end is screwed inside the engine cylinder, whereas the other threaded end is there to receive the ignition lead. So this end which goes inside the engine cylinder, that threaded portion of the spark plug is the reach of that spark plug. So the spark plug reach is the threaded portion. You can see this is the threaded portion of the spark plug that is screwed in the spark plug bushing of the cylinder. Proper reach spark plug ensures electrode end of spark plug at the right position to fire. So this is very important that you have the right reach of spark plugs. You are using the right reach of spark plugs so that the electrodes are at the right position to fire in the engine cylinders. In case long reach spark plugs extend into the combustion chamber and its threads will be exposed to carbon. So in case we are using long reach spark plugs, they will extend into the combustion chamber and its threads will be exposed to carbon. And if carbon clings to spark plug threads, it can become a source of pre-ignition and can also make it very difficult to remove the spark plug. So it is very important that we use the right reach of spark plugs. In case long reach spark plugs are used, in that condition the spark plugs will extend into the combustion chamber and the threads will be exposed to carbon, and when carbon clings to these threads, they might become a source of pre-ignition and it can also be very difficult to remove these spark plugs. Use of improper reach spark plugs can become a cause of improper combustion and can also result in spark plug seizure. So improper reach of spark plugs, they have various problems. They can lead to improper combustion and also spark plug seizure. It is thus very important to use the approved spark plugs recommended by the manufacturer of the engine. Now this was all about the ignition system, the basic ignition system of a reciprocating engine. We have seen various parts, we have seen the basic theory involved, we have seen the items, the units of the ignition system, we read about the switch which controls the ignition system, we have read about the magneto, the basic theory of the magneto, we have seen the different parts of the magneto like the magnetic circuit, the magnetic rotor, then we have seen the primary circuit where we saw the primary coil, we saw the breaker contact points, we saw the capacitor, we have seen the function of these items, then we saw the secondary circuit and how this magneto was operating. Then we have seen the ignition harness, how the ignition harness is acting as a conducting path for the high voltage developed in the magneto. Then we saw the spark plugs, the different types of spark plugs, the purpose of the spark plug and the importance of using the right type of spark plug as recommended by the manufacturer. This was all about the basic ignition system. During the course of maintenance, during the course of operation, we may encounter several snags, we may encounter several problems both during flying, during ground operations, during maintenance. Some of the problems have been summed up here, and let us see what are the problems we face in the ignition system, what are the probable causes and what may be the solutions for them. So, the first problem in case if we are facing hard starting. So, now if you are facing a hard starting problem, what may be the cause? The causes may be worn or fouled spark plugs or arcing ignition lead. So, your spark plugs are worn out or fouled or your ignition leads are arcing. Second reason may be impulse coupling is not operating properly. In case the impulse coupling is not operating properly, then also you may face hard starting. Third probable cause is impulse coupling is magnetized. Now, your impulse coupling is magnetized, that may also lead to hard starting. Another cause, retard contact assembly in retard magneto not operating electrically. Engine may kick back during cranking due to advanced timing of the ignition. So, this is also one of the cause. Another cause, magneto improperly timed to engine. This is a very important thing, that magneto should be properly timed. In case if it is not properly timed, then also we may face hard starting. Main contact assembly out of adjustment. Now, in case your main contact assembly is out of adjustment, then also we face hard starting and retard points opening too late. So, various reasons of hard starting. Let us see the solutions one by one. In case if the spark plugs are worn or fouled or the ignition leads are arcing, then we need to inspect and replace or repair as necessary. In case the spark plugs are worn out, then we need to replace the spark plugs. In case the spark plugs are fouled, we need to remove them, we need to clean them properly as per the recommendations of the manufacturer. We need to set the gaps right as per the recommendation and install them back. And in case the ignition lead is arcing, we need to see if it is to be replaced. Second probable cause was impulse coupling not operating properly. In that case, we need to remove and check for binding, worn or broken impulse coupling parts. We need to remove the impulse coupling, we need to check in case if there is any binding, in case if it is worn out or any parts are broken. So, in that case your impulse coupling is either to be serviced or to be replaced as required. Third cause was impulse coupling is magnetized. In that case, we need to remove the impulse coupling and demagnetize it or replace the impulse coupling. So, in that case, either we remove it and replace it with a new impulse coupling or we remove it and demagnetize it. Inspect engine for magnetized components and demagnetize all such components. Another reason was retard contact assembly in retard magneto not operating electrically. In this case, we need to see that the retard points may not be closing due to improper adjustment, or may not be electrically connected in the circuit due to a poor connection. So, the adjustment may be improper or the connection may be poor. Inspect retard points to see if they close. Check for proper contacts at the switch and retard terminals of retard magneto, and at the vibrator check wiring. So, this is about retard terminals and retard points and the vibrators. We need to check the wiring. Magneto improperly timed to engine. In that case, we need to check the magneto to engine timing according to the engine manufacturer's instructions. Inspect contact assemblies according to the instructions and replace parts as necessary. So, we need to time the engine as per the manufacturer's recommendations, and further required we can inspect the contact assemblies and replace the parts as required. In case main contact assembly is out of adjustment, internal timing is off, then we need to check the magneto internal timing according to the instructions. So, this timing is very important, both internal timing and external timing, timing to engine as well as the internal timing. As part of a regular maintenance, as part of a regular inspection schedules, it is part of inspection where we need to check whether the magneto is properly timed to engine. Retard points opening too late. Check timing of retard points according to instruction. Now, this was about the probable causes of hard starting of engine. Second problem which may be encountered is rough engine operation. Engine is operating rough. Then what may be the reason? Worn or fouled spark plug, this may be the first reason. Then worn ignition leads, your leads are worn out, your spark plugs are worn out or fouled, your ignition leads are worn or fouled magneto contact assemblies. Now, magneto contact points, they may be worn out or fouled. Carbon tracked distributor block. Now, there is carbon tracking on the distributor block. In that case also you may have rough engine operation. So, let us see the solutions for all these causes. In case your spark plugs are worn out or fouled, in case if they are worn out, they need to be replaced with new ones. In case they are fouled, we need to clean them and set the gaps correct and install them back. In case the ignition leads are worn out, check the plug leads for continuity and breakdown. In case your magneto contact assemblies are worn or fouled, in that case also the magneto contact assembly for burning, melting or contamination should be checked according to the instructions. So, the magneto contact assemblies, we should inspect them whether they are burnt out, melt or contamination. In that case, whatever needs to be done, we need to either do the maintenance action or replace it completely. Carbon tracked distributor block, it is better to replace the distributor block. Another problem is of magneto drop off, check out of limits. So, your magneto drop is out of limits. Let us see what are the reasons. Magneto to engine timing is incorrect, that may be the first reason. Contact assemblies are not operating properly, that may be another reason. Main contact assembly out of adjustment or your internal timing is off. Faulty plugs or leads, that is another reason. No drop off noted, open switch connection and carbon tracked distributor block. So, there are several reasons, several causes of magneto drop out of limits. So, let us see one by one. In case your magneto to engine timing is incorrect, then in that case we need to time the engine as per the manufacturer's recommendation. In case the contact assemblies are not opening properly, in that case also as per the manufacturer's instructions, we need to inspect the contact assemblies and take appropriate action of either cleaning it or replacing it. Main contact assembly is out of adjustment, that is your internal timing is off, then in that case also we need to check the magneto internal timing as per the manufacturer's instructions. Now, your plugs, spark plugs are faulty or your leads are faulty. In that case, if the plugs needs cleaning, we need to clean them and install them back, and in case if they are to be replaced, we need to replace the plugs or the leads in case if they are faulty. No drop off noted, open switch connection. In case there is no drop and there is an open switch, then we need to check the capacitor according to the instructions. And in case if the distributor block is having carbon track, in that case we need to replace the distributor block. So these were the probable causes and solutions for magneto drop off out of limits. Another problem that may be encountered is radio noise. So what are the probable causes? Let us see. First is faulty spark plugs. Second is frayed shielding at spark plug terminal, magneto cover or intermediate point on harness lead. Third is inadequate shielding ground at spark plug terminal or magneto cover. So various reasons for radio noise. In case if you have faulty spark plugs, then in that case we need to replace the spark plugs. In case there is frayed shielding at spark plug terminal, magneto cover or intermediate point on the harness lead, it is better to replace the ignition lead. And in case if we have inadequate shielding ground at spark plug terminal or magneto cover, we need to remove and replace the inner ferrule according to instructions. So as per the manufacturer's instructions, we need to inspect, we need to perform proper inspections, maintenance actions and take the corrective action accordingly. So this was about the ignition system. We have seen the various units used in the ignition system. We have seen the various problems faced in the ignition system. Now in our next video we will see these parts physically, how these parts operate and how they are fitted on an aircraft. Thank you.